Today's episode is sponsored by Meter, delivering a complete network as a service offering, wired, wireless, and cellular in a unified solution. Find out more at meter.com/N4N. That's N, the number 4, N. Welcome to N is for Networking. I'm Ethan Banks with Holly Metlitsky, and if you've not listened to our show before, we are glad you're here. And the format of our show is that I've been around networking for about 30 years, and Holly closer to 3, and we have conversations about networking technology based on what she's seeing through fresh eyes and what I'm seeing through my time in the packet trenches. And today's discussion is an overview of firewalls. While I would say cybersecurity, it's a different discipline from network engineering, right? But there is this significant amount of overlap because of much of what happens in cybersecurity. It's really interesting at the packet level. And so it happens that network engineers find themselves fairly often in the security business. And so it's likely that as a network engineer, you're going to be managing firewalls at some point in your career. And so I wanted to have this chat about this, Holly, because we have not covered firewalls at all yet, I don't think, right?
Yeah, not that I can recall.
No, I know it's come up and we mention them, but we haven't had that discussion about what a firewall is. So do you have a take on this? Do you have an impression on what you think a firewall is?
I do. Not to confuse anybody, but when I think of a firewall, I think about almost like a specialized router. It is not, its primary function is not to route, but it can. But on top of all of that, it's got a bunch of security features. It's kind of like a entry point into a network where it's analyzing the packets coming in, deciding what's good, what's bad, what are we letting in, where they're going, and things like that.
Yeah, you've got a good, I think, a good grasp on the fundamentals of what a firewall does and is for. And I think if we think of the word firewall, what is being implied there is also interesting. If you build a house or if you have an automobile, there's a firewall potentially involved there. That is a wall that was specifically constructed to keep fire contained. It shouldn't proceed beyond the wall. So in your automobile, the firewall might be between you and the engine. You know, you're inside the car, and there's a firewall, that bit of metal that protects you from what might be a fire in the engine compartment. And in building structures, there are firewalls too. That the same thing. And we could think of a firewall in that way. We're trying to keep the bad stuff on the other side. Stay away, bad stuff. Now you mentioned something interesting, Holly, about the function of a firewall as relates to routing. We've talked a lot about routers on this show, and we've had shows that dive into what a router does and how it determines how to take a packet that flows in on one port and send it out on another port. And a firewall, right, it's not a router, but it definitely routes, right? It's got a routing function. It has to know how to move traffic from one port to another, but that's not its job primarily to be a router. It's not how I think of it. I think of it like it's like a traffic filter, or maybe some
Mhm.
people use the analogy of a traffic cop. Um, Traffic that is allowed by a firewall security policy will pass. It will be routed by the firewall, while other traffic is dropped. You know, and that's the key difference. A router, it's unless it's overwhelmed with congestion, like we were talking about in the QoS episode, and there are drops. A router, generally speaking, people are thinking, thanks, you can have access lists on routers that cause it to drop packets like a firewall. Yes, we can. That is true, but forgetting that it's not the router's core function. The router's core function is to move traffic through, to route that traffic from one port to another, and to not drop it. A firewall's much more focused on, do I allow this? Yes or no? What is in my security policy? Do I see anything weird going on inside this packet that makes me go, that violates something. I don't feel good about that, and then drop that packet. So that's, to me, the it's a philosophical difference between a firewall and a router. Am I making sense?
Yeah, I think this ties into some of the conversation about our switch versus router conversation that we had very early on.
On a level.
It's
Yeah.
about like, what is the core purpose of the device? Yes, it can do other things, but what is it truly built for? Like, I learning when I first started at Juniper, I used a firewall as a router. I just deleted all the security policies because I need like a really small box to play with.
Mhm.
But that's not what it's meant for.
No, and to speak to Juniper specifically, if you have an SRX firewall, it's if as I recall, it's been a while since I've been on one, but it's a zone-based firewall.
Yep.
And you look at the operating system, and it's Junos, and it feels just like a router. The command syntax and the structure and how you write all those commands and so on, they're the same as a router or a switch running Junos. Only you've now got these other additional features and functions that have been added to the box to give it that zone-based firewall functionality, which blurs that line even more. Then it's like, wait, what am I on? And I used to have to
Uh-huh.
pay attention, like, oh, I'm on the firewall right now. Hang on, that's like because it looks so similar. And other firewalls aren't always that way. I worked on Cisco Pix firewalls way, way back in the day. Those became ASA firewalls later, and now there's several other Cisco firewalls that are out there with different operating systems. And those were quite different. You hop on those, and there were similarities to Cisco iOS, but you knew pretty quickly you were on the firewall console because it was quite distinct, the command line configuration as you were to look at those stanzas. But yeah, again, there is a bit of a blurry line, like between switches and routers. Sure, there's a lot of they're different, but they're kind of the same, and you're squinting a bit to understand what the difference is sometimes, and it can be that way with routers and firewalls too. Well, okay, I think if we keep talking and explaining more about what firewalls do and how they function, the difference is going to become clearer for everyone. So let's lean into this notion of a filter, a traffic filter. A firewall typically filters at layer three, but I will say that layer two firewalls are a thing. Have you run into this
No.
idea of either, so layer three
Layer
firewalls,
3,
I'm going to
yeah.
guess yes, but layer two,
Yes.
no?
No, not layer 2.
Yeah, layer three firewall is the most typical sort of a deployment. Traffic is destined to the firewall. The firewall is perhaps a gateway for a particular network segment. Traffic arrives at that firewall and then gets routed at layer three and moves on. Layer two firewalls, that is, you're filtering at the Ethernet level in this implementation, do exist. Those are a thing, and they're referred to as a bump in the wire. They're more of it's like you're putting the firewall in line on a layer two segment, so traffic is passing through it, even though you didn't aim traffic at it as if it were a gateway or a default gateway for a
Mhm.
particular segment. So I just wanted to we don't need to get into layer two versus layer three firewalls, other than I wanted to mention layer two firewalls exist or they have existed, and you might see those things out there. It's just a different way of doing things. The most typical implementation is at layer three.
So, you're like, "I just wanna mention it, but now I'm curious." So if you have a a purely layer 2 firewall, in
Yeah.
that scenario, it is truly just a firewall because it needs to be in line. It's almost closer to a switch than it would be a router because it's not routing,
Yeah.
it's just I guess the frames are coming in, being inspected, and going out the other side if they meeting the
Mm.
filters.
Yep. And going back to that bump in the wire
Yeah.
analogy. Yeah. Yeah,
Okay.
exactly. I think that's the best way to think about it. Yeah. Okay. Historically, firewalls, you would think of them as a physical box, some kind of something in the rack with ports on it that straddle the border of a trusted and an untrusted network. Now, I say historically, and that's important because I think in 2026, as we're recording this, the world's a little different. But again, going back in time, this is how you would have thought of a firewall. This is a box that I want to protect me and my network that I trust and love dearly from probably the big bad internet would be the most typical use case. So your LAN, your local area network would be trusted and the internet would be untrusted. And that firewall sits in the middle. Now, if we update that for today, I think a modern view that is more correct is that no network should be trusted, even your own, because bad actors get into your network and then can use your network to amplify itself, to move around, to they can get if they can get any kind of a beachhead inside your network, they can use it as a jumping off point to get to anywhere else that's within your network. And because of that reality, the way firewalls are thought of and are deployed has changed somewhat, where it's not as simple as I've got a firewall that separates my network from the internet, and that's all a firewall does. Yeah, not really. You end up with firewalls all over the place now in various forms, and we'll talk about that in a second. But one other analogy I want to make for folks is you don't. I mean, we talk a lot in this show from an enterprise context, like a business, a company that's doing networking, but you've got a firewall sitting in your house, almost certainly. You've got some kind of a residential router that your ISP provided for you or that you purchased at a big box store somewhere. It might have Wi-Fi on it as well. And it's probably got LAN ports on it, so you can plug your access point or your other parts of your network into it if you've got anything like that. And it's got a WAN port that you plug into your ISP's, like your cable modem, or typically something like that. Or it could be a box that's all in one. It's your cable modem, access point, everything all in one. But it's a firewall. That's what it's got, a firewall inside that's protecting your internal network from the big bad internet. And so if you never thought about that device that connects your house to the internet in that way, it's definitely a firewall. It's got firewall functionality.
Yeah.
Just curious, Holly, what have you got at I don't know what your internet setup is at home, but you must have a
It's
firewall of some kind.
yeah. I mean, I have an SRX. It's not plugged in, but I have one. And
Yeah.
you know, small apartment, New York City, electricity. But my home little router thing that came from Spectrum, that all-in-one device, if you
Yep.
actually
Yep.
go into the interface, you can configure some firewall policies or certain filters if
Yep.
you want. And
Hmm.
I've looked into that just for fun, um, which is quite interesting. But when I do some lab exercises, I plug in my SRX and I've got a switch and, play around on that front as well. And like you said, that then I have a firewall, physical Juniper firewall in front of my home router firewall Wi-Fi device all in one, which
Hmm.
also has firewall policies in. So
Hmm.
it's
I've seen that happen too. I used to have Spectrum too, once upon a time. I'm trying to remember the device they gave me. It was a cable modem, access point, all in one, magical thingy, most of the
yeah.
functionality of which I did not need. I actually just needed I just need you guys to use the cable modem to connect me to the rest of the world.
Hmm.
That's it. I provided my own firewall. I have my own access points and so on. But that's not the most typical deployment. I mean, we're nerds, so yeah, we end up doing things like that.
Yeah.
But the average house is gonna have that device from Spectrum, whoever the ISP is, that does all the things, including firewalling. And exactly what you said, you can log into that thing if you've got access to it and you get in there. Yeah, it's firewall rules you can poke around with. There's probably a default firewall rule set that says something like, if you're coming from inside the network and going to outside the network, it's allowed. But if something's coming from outside the network and going to inside the network, it's not allowed. And then a few other, default little rules like that. Probably a set of 5 or 6 of them or
Mm.
so. Maybe some for IPv4 and a few other ones for IPv6, depending on what your network needs to support. And that's it. But there is firewalling functionality there. And then if you're a gamer, you might be concerned about port forwarding. I want to be able to get traffic from this game and this server on this port and allow it into my gaming rig. So people might punch holes in their firewall to allow those sorts of things. And if you've done that thing, you've been messing with the firewall. You've been messing with the security policy on the firewall. That's what's going on there. But firewalls are not just physical boxes that have interfaces on them like a switch or a router. They can take other forms too. So we've got virtual firewalls on all of our desktop operating systems, Windows, Mac OS, Linux. There are virtual firewalls that we can set up there. I say virtual because it's software running on top of our laptops or our servers. that can be running. They aren't always running. If you don't want them to be, you can shut them off, or you can turn them on. And different, like Linux, if you're using, oh, it used to be IP tables. They've updated it to something else now. I forget the name of what it's iterated to at this point, but you don't have to have that turned on, and maybe it isn't by default, or maybe it is, depending on what distro of Linux you're running. Mac OS has got a built-in firewall, uh, so that you can protect your machine from the rest of the world, and so does Windows. Those are all built in there. It's that you mess with any of these? I don't know what you run in your laptop. Are you a Windows or a Mac
It's
person?
I'm a Mac person, but
Yeah.
like mostly all corporate stuff, so I can't change much on it.
Oh, okay. So IT has your rights heard on your
Yeah.
laptop from afar. So
Mhm.
I'm almost
Yeah.
certain there's going to be significant firewalling that they have
Oh,
added to
100%.
your laptop, to the point of it maybe at times being annoying to use because it's so secure. I'm going to guess.
Yeah, when you just get locked out like I am currently because it's so secure and
What did you do?
Mhm.
Yeah.
Story for another day, but no, it's
Story for
it's
another
got all
day.
of it.
Yeah. Yep. So we got physical boxes with interfaces that are a firewall. We got virtual firewalls that run on our operating systems. We have distributed firewalls, that and what these are firewalls that enforce security policies across, like, virtual machines running on a server that's got a hypervisor on it, like VMware. If you're running a VMware or Proxmox, um, a system that's got a hypervisor that you can run virtual machines on top of, you might have a distributed firewall being a part of that system. VMware had technology. They've rebranded a million times, so I'm probably not even close on what their current branding is, but the platform was NSX. And NSX is a distributed firewall that can run on a bunch of different servers that have instances of hypervisors running on them, and do firewall security for those virtual machines that are running on that platform. So a distributed firewall that's running not in one central place, but all over the place across your hypervisors and virtual switches and so on. It's another model that you'll see out there. Um, there are firewalls that can run as a virtual network function on a SmartNIC. SmartNIC, you might also see them referred to these days as DPUs, data processing units. But it's a card you plug into a server that's got its own chip on it that can do things. It can run various kinds of software, and one of those pieces of software might be a firewall that you're running on that DPU. Um, Okay, so distributed firewalls. I don't know if there's anything in the Juniper portfolio that does that, Holly, although there certainly might be. Your portfolio is rather vast.
I was gonna say I'm mostly in like the physical hardware space, so I haven't run
Yeah.
into that yet. It is possible that we do. I just haven't sold it yet.
Yeah, I'm trying to remember again. Juniper's got lots of branding and different
Yeah, I mean we've got I know we've got
software
virtual
groups and so on.
firewalls, of
Mm.
course.
Yeah, you can run
Um,
VSRX, for
yeah,
example. I know that's a thing that's out there. Yeah. Yeah, which is another good point. It's a subtle distinction we haven't made, but if you want to play with a firewall in a lab, like I think VSRX is a thing that you can do. I
mhm.
don't remember what the licensing requirements are or whatever, but I know that's a thing. If you wanted to run a virtual firewall as a appliance in your lab, those things exist. That is a software version of the hardware, what you would think of as the hardware. You run into this SmartNIC DPU thing? Does that come up in your
That
world?
I have not.
So this is a growing segment, a growing market segment that is good to be aware of. It's a little esoteric, but it's not like everybody's buying these. But I think more and more we'll see these where you can buy a server that's equipped with a DPU, a data processing unit,
Mhm.
aka a SmartNIC, and offload functions from the main server, from the compute function of the server that you want to run containers on or virtual machines on, and offload it to that NIC. Hey, I don't want to do any networking stuff and tie up my server doing those tasks. I'd rather buy a specialized smart NIC and run the firewall function on that. That is a philosophy that some folks have because it's better power efficiency, it's a better cost model, it frees up more CPU for them. There's a lot of reasons why you might or
Mhm.
might not do it depending on your compute workloads and so on. So, more to the point, hey, virtual network functions, VNFs, are a thing, and firewalls are one of those sorts of things. And maybe you'd see that happening on a smart NIC. So, if you're at a company that is doing big data centers, you might see that model in action. More to the point, firewalls take many forms. That's all I was really trying to say. You see them all over the place. All right, you ready to dive into how a firewall is different from a router in a little more detail?
Let's do it.
Okay, let's do it. So we said a firewall does route, right? The
Mhm.
typical implementation is that a firewall does indeed route. It's going to forward packets between interfaces that are on different networks. But the purpose of the firewall isn't to route as such. That would be, more how we would think of a router. A firewall's purpose in life is to make a decision about which packets should be routed. And there's a lot that goes into this firewall's decision to either forward route a packet or to drop it. Um, we mentioned a little earlier that a firewall might have the concept of an inside network and an outside network. An inside network, I'm connected to the trusted network, and an outside network, I'm connected to an untrusted network, the big bad internet. And a default security policy, like you're going to get in your home router, would be to allow traffic to flow from inside to outside, but not the reverse. Philosophically, that makes good sense. If you if you does this feel right
Yep.
to you?
Yep.
Yeah.
Always trust to untrust policies because
Mhm.
what you know is coming, what's in that trusted zone. What's on the other side, just let it out. It doesn't really matter because it's leaving.
It's
But
been a while since I've looked at SRX, and I know it's zone based, but they
yeah,
have that
yeah,
notion of trusted and untrusted.
yes.
Okay, okay, good. So then, okay, now not all firewalls have concepts of zones for what it's worth. That is something that's a bit different. That is, if you see ZBF as an acronym, zone-based firewall, or the mention that this particular firewall works as zone-based, it does imply that how traffic flows through it philosophically is maybe a little different than some other firewalls. And I like the SRX from Juniper. There's a zone-based firewall. A zone-based firewall is going to group physical interfaces into a zone, and then you write policy to allow traffic to flow between zones. And
Hmm.
you're not worried about interfaces here because you've grouped interfaces into zones. So you care about the zone, and you just put interfaces into the zone that it needs to belong to. Is that
Yeah.
that jive? Yeah.
Hmm.
Other firewalls, you're thinking more about IP addresses and groups to route between interfaces. You're not thinking about zones so much. It's a subtle thing, but it's a little different way of thinking about things. Zones, in my opinion, give you a little more flexibility.
Yeah. I mean, I've only really dealt with the Juniper Zone side of things. So it's
Okay.
interesting. It would be interesting to dive into some other firewalls and see the differences between that.
Okay. So we're thinking about how firewalls look at moving traffic through them. So some have this concept of inside to outside, trusted to untrusted. Some might have this idea of zones to stack onto that, where it's not simply a trusted interface and an untrusted interface and flowing between them. It's a zone where we're actually taking the physical interface and putting them into a zone, and then deciding what traffic moves between the zones rather than the interfaces. Then yet another thing that's really interesting here, because this threw me the first time I saw this as an engineer that hadn't run into it before. There are firewalls that have out of the box deny all traffic. That is their philosophy. You plug in your you plug in interfaces, cables into this firewall. It'll drop everything. It's default behavior. Certain firewall makers take this position. Historically, I haven't touched a checkpoint box in 20 years probably, but this used to be there. The first time I ran into a checkpoint box and was setting up one from scratch, it absolutely threw me. It's like, man, I got nothing through this. I've configured different interfaces and so on, and I know that it's talking to the network and it's seeing traffic. It won't pass anything because I was expecting trusted, untrusted, more of that philosophy, and I'd at least be able to get to the internet with this thing. But the at the time, at least, or maybe it's still the same today, I don't know. The checkpoint philosophy is to deny all traffic. And so you
Which
got to build a policy from scratch.
kind of makes sense if you think about the purpose of a firewall. It's to make sure that it's protecting your network. So if you just plug in a firewall thinking you're creating some kind of buffer or safety, and it's like, okay, well, from scratch, I'm just going to let it all through. Well, it depends which way you want to go. Do you want to configure policies to deny things, or do you want to slowly allow more traffic to get through? It's
And from a corporate perspective, if your goal is to maximize security, then yeah, exactly. Once I got it, what was happening with that firewall, like, oh, the point of this is not my convenience like I want at home with my residential router, where, like, yeah, the default posture is allow everything that starts from inside the network on the trusted side to flow to the outside. Yeah, that makes sense. I don't necessarily want that from a corporate perspective. And I remember hammering my head on this for a while. But what if your network has been compromised and is being used as a launching point to attack other hosts that are out there on the network? Do you want your firewall to allow those attacks originating from your network to head out the door? No, you don't want that. For example,
Mhm.
do you want to let everyone on your network go to everything that might be out there on the internet? Well, no, you want to filter that stuff. You've probably got a control policy that forbids people from going to, I don't know, the dark web or gambling sites or porn during the workday. You might be filtering all that sort of stuff, and you're not going to allow anything until you've got a policy in place that specifies what is allowed and then is blocking and filtering everything else. So, yeah, I agree with you. It makes all the sense in the world to start that way. But if you're not expecting it, it can really throw you for a loop.
Yeah. Since I think
Why
it
can I get
depends
nothing through this?
it depends on your level of security. I think a lot of if you are looking to only deny a few things, starting with denying all is going to take quite some time to then figure out all of the things you're allowing to flow. But conversely, if you're really only looking, I don't know, for very specific internal traffic to move to specific places, it's much easier just to deny everything and add a couple policies after that to allow certain traffic.
Uh, yes. I- and if you're starting from scratch, it's also harder than if you've are adding a new firewall for a new site and you've already built a kind of a
Yeah.
template policy for the company. It's that then it's easier. Just getting over that initial hurdle can be the hard part too. All right. So another point here about how a firewall is different from a router. So we've talked about filtering. A firewall is making a decision to allow or deny traffic. It's got this mode, this mental thought of I'm going to drop it unless I've got a reason to allow it. That's pretty different from a router. Another idea here is that a firewall tracks connection state, and it knows when packets are showing up unexpectedly because it is tracking this connection state. Do you know what I mean by connection state?
Kind of, but not really. Like, I think in my way back when, doing my initial certs, a lot of it was discussed with stateful and stateless
Mhm.
devices. And we know that firewalls are stateful, tracking states. What exactly is that connection state? I don't think that still lives in my brain.
Okay, perfect. Then this will be a great conversation. Uh, do you remember what the TCP three-way handshake is, or has that
Yes.
ring a bell with you? Can
Yes.
you? This is not a nice thing to ask you
I was
right
going
now
to
if you
say,
haven't
is
reviewed it in
this
a
like
bit,
a
but
technical interview? You're asking me to
it.
go through all the different states? I'm starting to sweat here. I mean, an act goes one way, there might be an act another way. At some point,
Yeah,
they've
yeah.
agreed. The
Okay, okay.
technical terms for
So
that, bit fuzzy. But
so let's back it up. The TCP three-way handshake is the process two devices go
yeah,
through to establish a connection. The three-way handshake, the initiator, I want to talk to you. So it's your computer wants to talk to a web server, and it's going to open up a socket on port 443
yeah,
HTTPS. So to establish that connection, if you were to watch this in Wireshark, you would see a the TCP three-way handshake happen. Your computer is going to send out a TCP with the SYN flag set, SYN. Um, the server is going to receive that, and if it's got an available socket that it's able to open, so you can establish that connection, it will respond with a TCP packet with the SYN and the ACK flags sent. Hey, I'm acknowledging your SYN. I'm trying to remember what SYN stands for. Synchronization, probably something like that.
Yeah, I think it is.
Um, the acknowledgement SYN and ACK flags come back. So that's your second packet that's returned to the client. So SYN goes out, SYN ACK comes back, and then you send an ACK from your client back to the server to establish the connection. SYN, SYN ACK, ACK, three-way handshake. When that final ACK goes back, now you've got an established connection. And what's happening, if you look at this in Wireshark, you're going to see flags set in the TCP header. When we say SYN, the SYN ACK and ACK, there are other flags too, like FIN, to finish a connection. Um, those flags all have meaning and should show up at a particular time in a particular place in a particular order. It would be weird if the firewall, having not seen a TCP SYN go out from your client, to be receiving a packet from the server that's got SYN-ACK on the way. It's like, oh, wait a minute. That's the second part of a TCP three-way handshake, but I never saw the first one go out. So the state of the connection is invalid. We're tracking state here, and to get a SYN-ACK without a corresponding SYN that went out ahead of time doesn't make any sense. Why would I be seeing that? So I'm gonna drop that packet. That doesn't make sense. Why would I receive a fin packet coming in, a finish? I want to initiate the process to terminate a connection. If I don't have a connection, that's weird. So I'm going to drop that packet. So the firewall is tracking connection state, again, is what's going on here. It knows the state of a TCP connection, and knows when packets with flags set in unexpected ways has happened, because it's looking into the TCP header and tracking that information in its state table. You can actually see a state table and know exactly where a connection is in its life cycle, and the firewall is paying attention to all those things. And if anything weird is going on, it's gonna drop that traffic. A router probably doesn't care about that stuff.
So that's for TCP because we know it's an acknowledged
Yep.
protocol. But then what happens with state tracking for unacknowledged protocols like UDP?
Then there is no state for UDP.
Yeah.
You're right, because traffic is just flowing. It is an unacknowledged protocol. So in part it depends, but the big answer is, was the connection UDP traffic isn't going to flow from the internet to a host inside unless the host inside did something to initiate that connection. There's still might be
Yeah.
some sort of state that needs to be tracked. Did it flow in the right direction, or is traffic coming from a network I don't trust appearing without anything happening on the inside to initiate it? TCP, it's easy to explain exactly what's going on about state because we've got these
Yeah.
flags in the header and an expected behavior. UDP and various other protocols that don't have that sort of acknowledged behavior, right? It is different, but there is still some kind of firewall paying attention to what's going on. And it may be protocol specific, whether it's UDP or something that rides on UDP that the firewall might know about, to know that this is or is not a valid connection. It's still paying attention, even though with UDP there isn't state in the way that we mean it
Okay.
with UDP, in the way that we mean it with TCP. So I'm sorry for the vague answer, because the answer is it depends, and it
Yes.
can get as specific as the layer 7 protocol itself, what's going on, and how the firewall interprets that state and keeps track of it. Another weird curveball here I can throw at you is the stateful nature of a firewall means that if you have asymmetric routing, traffic goes uh, out the network in one place that that firewall didn't see, and then comes back in through the firewall, means the firewall didn't see the whole conversation and thinks something bad is going on here because we didn't route in a symmetrical way. We went out one way and came back in a different way. If the firewall doesn't see the entirety of the connection as it's being set up or torn down, it can think some sort of statefulness has been violated, something weird's going on, and drop the connection. That could be a problem. Now, that's a rare thing, but people that are getting into firewall placement and complex routing design and interesting data center challenges will have all seen this problem at some point where, like, oh crap, I got to force traffic to go back through the firewall symmetrically. I got to make sure that that is happening because it could be you might have multiple exit points from your network, multiple firewalls that are governing that traffic, and it leaves one firewall and comes back in a different firewall, and both firewalls are like, nope, that no bad things. So symmetry in your routing in and out via the same firewall matters a bit. That's a bonus. Just it's one of those fun problems, classical problems that you run into in network design and with firewalls.
Is there a way to have asymmetric routing and tell your firewalls that this is okay?
Our sponsor, Meter, is a network as a service company, and that means a Meter network is a tightly integrated stack of network hardware and operating system software delivering wired, wireless, and cellular service. And they deliver that gear to your premises as a service such that the fussy parts of network operations are handled by Meter for you. So for example, you don't have to worry about upgrading a switch to make sure that it stays secure. Meter's got you covered. Plus, they monitor your network remotely. So no matter how big or small it is, from branch office to a data center, Meter can handle it. Meter does more than ship you gear. They also take care of everything needed to bring a site online. Internet, wireless site survey, cabling, that is all part of what the Meter offering is. The networking stack is going to give you all the things that you've been learning about on NS for networking: routing, switching, wireless, firewalling, security, cellular, intelligent power, DNS security, VPN, SD-WAN, and there's more stuff in that offering too. Now, in fall 2025, I did a video on the Packet Pushers YouTube channel showing you a Meter stack, and I'm going to do an updated video in 2026. Why? I was at Meter's headquarters recently, and I got to look at their new hardware and a preview of their software updates, the things that that's coming soon. And these guys are iterating fast. And there's a vibe. There was a vibe when I was there. I felt this genuine thrill of enthusiasm from the Meter folks who I was talking to. 100%. The Meter team is excited about what they are building. So thanks to Meter for sponsoring. Go to meter.com/N4N. That is N, the number 4N, to book a demo now. That is Meter, METER.com/N, the number 4N, to book a demo. Maybe. There are some firewall systems I've run into in the past that can share state between them. So Firewall A and Firewall B kind of know about each other's state. That is a thing I am aware of that has existed. Is that a normal way to do things? Oh gosh, I would say no. I don't think we really see that in the wild. Typically, if you're out there listening and you're like, "Oh yeah, we do that here," because reasons, send us a follow-up. I would love to hear about your specific design and why that happens. Don't, give away any security details, obviously, but would love to hear in general that you do that, what the firewall platform is that supports that, because there's a lot of state mirroring that's got to happen there. In that scenario, is it a cluster that you're doing that on, and and then why? For me, it was always, when I ran into that, it was like, oh, shortest path converged in a weird way and made traffic leave one firewall and come back in a different way because of the way BGP converged for us. It was these sorts of problems. Okay, we got more things to talk about, Holly, about how a firewall is different from a router. And another one is that a firewall is performing DPI, deep packet inspection. And that means that the firewall looks beyond the packet headers, IP headers and TCP or UDP headers and so on, and they're looking deeply into the payload, which means what to you?
It means they're actually looking at the contents of that packet. So usually, if you're just looking at headers, you say, okay, it's going to go from here to here and off we go. But it's stopping, it's looking, is there anything malicious in this payload, whatever that could
Yeah.
be, instead of just assuming that it's safe and it's maybe the source is trusted. So you're not worrying about it, but it's still going to look into what's actually being sent or received.
A a router's making forwarding decisions,
Yep.
exactly. It's looking at those headers and deciding as quickly as it can. It doesn't want to take the time as a
Hmm.
router to look into the payload more deeply and go, "Gosh, do I like what's in there or don't I?" That's a firewall's job. The router, wants to get that traffic forwarded as quickly as possible. The firewall will look beyond the headers and right into the payload and as you said, see if there's anything weird going on in there that it doesn't like and can make a decision to drop that traffic. Now, Holly, we know in 2026, 99 plus percent of the traffic on the internet, that payload's encrypted. So what do
Yeah.
you think that does to DPI?
Makes it very difficult to understand what's inside that payload unless if it's trusted and you have the decryption on your firewall because you know where it's coming from and it's like a tunnel, IPsec tunnel, for example, and the tunnel endpoints your firewall and it knows the decryption, sure, I can look inside the packet. Otherwise, well, I'm not quite sure how you inspecting that payload.
Yeah, there are, and it gets weird. Modern security techniques. Some companies will tell you, no, we can't see inside the encrypted payload. Obviously, if we don't have the key, if we're not the middleman, which
Mhm.
we'll talk about that in a second, because that is another architecture. But we'll get into that in a second. But let's just say the firewall is receiving an encrypted packet. Well, some firewall vendors will tell you, well, because we're monitoring connection flows and we're seeing all packets that flow through a connection and we're using artificial intelligence and machine learning on the back end, we can model what normal behavior is. And if we see something that deviates from baseline behavior, even though we can't see the contents of the payload, we can infer something funky is probably going on here, and maybe I want to drop this traffic. Uh, but that's part of a bigger, firewall system and an ecosystem that involves, the vendors' machine learning algorithms. But they can give you a more comprehensive intelligence and make educated guesses about how to treat that traffic. Let's just say, based on this traffic isn't flowing like I expect it to flow, and I can't see what's going on in there, but something ain't right. Something's not. I don't like it. The other scenario is what you were describing. It is possible for a firewall to be a proxy, that your connection to a remote website is actually going through the firewall, not simply passing through the firewall, but stopping at the firewall where the firewall can unencrypt your encrypted traffic, see what's inside there because it is basically faking out your client so that your client thinks it's talking to the website when it's really talking to the firewall. The firewall then can see what's going on, decrypt it because it's got those keys, and go, "Yep, everything's good," and re-encrypt the traffic, and then send it on to the server. The server brings that traffic back, hits the firewall. The firewall is doing that middleman thing, unencrypts the traffic, inspects it. Oh, everything's good. Re-encrypts it, sends it to the client. It's a proxy in that scenario, what's going on there. And we're not going to get into we have a show we want to talk about proxies in more detail, what's going on with forward and reverse proxies. We had someone request reverse proxies, and I wanted us to have this conversation before we had that proxy discussion. Um, when you ask a firewall to do that work, you're you're asking it to do a lot and you're creating some amount of administrative overhead for yourself because there's a lot of certificate management that goes on, to do that, to have the firewall do that work. I'm not saying it's a bad idea. And with certain updated versions of TLS, I think TLS 1.3, I don't even think that works anymore. I don't even think that's a option because of the way TLS works. They don't want a middleman proxy to be doing that. Um, Boy, I think that's the case, but that is an architecture that exists, for sure. Okay, boy, that was a lot about deep packet inspection. All to
It's an
say,
interesting topic.
oh, it's a super cool. Oh man, I'll tell you what, just cybersecurity in general
Yeah.
is super cool. And there are definitely network engineers that have made the leap and said, I'm just a security nerd now. This is what I do, because they liked firewalls and all the other craziness that you can get into with what's going on across the network. Really interesting stuff, for sure. It could have been me. I didn't go that way ultimately, but yeah, I get it. I get people who did make that jump from pure network engineering into cybersecurity. Another thing that a firewall does that a router can do but typically doesn't do is network address translation. Now, if you're going, ah, banks, come on, man, firewall's definitely NAT. They can, but do you, as a network architect and network engineer, typically ask a router to do NAT? I mean, maybe in isolated cases, but the most typical use case for network address translation on the average LAN, Holly, do you have an opinion on what that typical use case is
For netting,
for natting? Yeah.
it's usually the edge of your network. So your
Hmm.
connection between your LAN and your WAN or your ISP internet.
Exactly. Do you remember RFC 1918 that we talked about? I don't know, many moons ago when we were
Yeah.
talking about IP addressing.
Yeah.
But RFC 1918 is the one that's the document that describes the private IP addresses that are not routable on the internet, but that you will use internally as a way to preserve the global number of IPv4 addresses that uh, the regional internet registries would allocate to different companies. We've been running out of addresses for a long time. We're out of IPv4 addresses global. There aren't any. So one of the ways we keep going is we use RFC 1918 addresses, 10 dot, anything starting with a 10, anything starting with 190, 192.168, those addresses, and then 172.16 through 172.31. All of those addresses are private addresses you use in your network to communicate. But when you need to go to the internet, those are not publicly routable addresses. And so what you do is you network address translation, you translate them to a public address that your uh, internet firewall has got some public address on the outside, and you translate from your RFC 1918 address, whatever you're using, to that public address that's on the outside of your firewall. And the firewall has this big job then of maintaining huge NAT tables to remember, when Holly's client laptop there went out to the internet, she came from this private address. I translated it to this public address on this particular port number. And when traffic comes back in, I got to remember to look at my NAT table and go, oh yeah, that's the Holly conversation, and then NAT it back to the private address of her laptop. And that's a big job the firewall's doing.
And is it fair to say that the reason why your firewall is typically doing that and not just every old router is because it's happening at the edge of your network? So typically,
Yeah.
you want the perimeter of your network to be secure, and that's why you're going to find firewalls performing this function. Like, yes, you might just have a router that possibly does this, but that's not typical because of security.
It is, I would argue that NAT is of communications
Hmm.
necessity, to
Yes.
go from that private IPv4 to that public IPv4 address. There is a long running argument in the networking community about whether NAT itself is security, is NAT security. And some people will say very strongly that yes, that is security because I have obscured my private IPv4 address that's actually assigned to my client when I'm inside the network, and I've hidden it behind this public address that I'm sharing with many other devices that are within my company. And so that is a form of security, security by obscurity. They would say, obscured my address. And other people would say, well, no, security by obscurity is not security. You've just translated an address. It's not a security function that's going on there. And the reality is, it's a bit of both. There is some amount of security you get by obscuring your address. Of course, there is. There's a little bit of security happening there, um, and you have to, of necessity, do the translation though as well. So I mean, it's a practical function. too. Uh, that said, would I ever NAT with just a router? Let's say not a firewall, but just a router, and a router can NAT. That's a very common function for a router to do. You fire up Junos and start digging through the docs, Holly. I'm sure there's NAT functionality buried
Mhm.
in there. I know there is for Cisco iOS, for example. Um, but why would you do it? Would you do it for security reasons? Well, no, you do it often because you've got overlapping IP addresses between two networks that previously were not connected to each other that now are. You're both running the same block from RFC 19. You both got 192.168.100 on your networks. And so the way you can get those two distinct networks running the same IP address space is to NAT, between them. I'm going to fake it out. I'm going to translate it to some other address that doesn't overlap with something that they're running and vice versa. And you can have a router do that. You don't have to have a firewall do that. It's not a security function. It's a communications enabler in that scenario. Yeah, you like this? No?
Yeah, I think so.
You thi-
I think so. I mean,
Did I answer the question?
I'm not sure about that. I think, like, in summary, like, the key thing is the reason why you find it typically on a firewall is because it's on the edge, and that it might not intrinsically be a security feature or security, but it's a necessity. And
Hmm.
usually where you are doing that is where you would find and slash place a firewall.
Yes, I agree with
Okay.
that, and that makes sense. Again, you do have to have it on that edge device where that firewall is performing that private to public address transit. It's the right device to do it. As you study NAT, we're not going to get into it now because we're already getting deep into the time here, but there's different flavors of NAT. There's NAT that is one to one. This one internal address gets this one external address, and they're kind of isolated from one another. But more typically, you don't have that many public addresses. You've only got one or maybe a handful of addresses and a bazillion internal private addresses. And so firewalls do something called NAT overloading, where they're taking a whole bunch of private addresses and hiding them behind a single IP address. This is also called PAT, port address translation. We won't talk about that in any more detail today, other than to say when you see PAT, we're talking about a specific flavor of NAT. A port address translation falls under the broader heading of network address translation. And there's lots and lots of documentation explaining what's going on and how that happens. And then one more point to make about NAT is there something I like to call it fancy NAT, and what I'm about to describe here, but that's not an industry thing, that's an Ethan thing. But fancy NAT is when you get into the way certain applications behave and announce things to each other up at layer 7 at the application level, they might embed an IP address in that communication. And some firewalls are aware that this is going on and will have quote unquote fancy NAT application fix-ups, they're sometimes called, that will translate the IP address in the protocol message to something appropriate, so that communication can so that communication can happen between the two devices. And if you get your fix-ups wrong, weird things can happen. This happens with like voice over IP gateways. That's a common thing. Back in the day, FTP needed to get fixed up, fancy natted. Just again, it's a thing to be aware of for sure. DNS, another common thing where this would happen. A lot of DNS happens in plain text. You might have a firewall that sees, oh, this request came from the outside, so I need to translate the answer that the inside DNS server gave with a private RFC 1918 address to a public address that the person requesting this record can actually get to. Things like that, where the firewall can be, you might think of it as quite intrusive. It's rewriting payload. It's rewriting layer 7 stuff. But that's a NAT function a firewall can perform that you turn on as needed when you have that specific application and use case. And in the world of everything's encrypted, probably far less of an issue in 2026 than it would have been even 5 years ago. Another way a firewall is different from a router, Holly, is firewalls are often used to terminate VPN tunnels, both client tunnels, B2B tunnels. That's a pretty typical use case for a firewall. Would you seen that too?
Yeah, yeah, very frequently. Which I'm gonna throw something in here, and I don't want to confuse anybody, but like some other devices that you get specific devices that are dedicated to like tunnel termination that
Hmm.
they
VPN
exist.
concentrator kind of devices, you mean?
Yeah, and there's just so many devices out there that kind of mirror each other and do the same thing, and it gets a little bit confusing. But I just wanted to make that note that firewalls do terminate tunnels. And just because you find something that is an edge device, or people call it gateways or whatever, that are tunnel terminators, doesn't necessarily mean that it's a firewall.
Yeah, it may have some firewalling functions, but its primary goal
Yeah.
is to handle VPN tunnels. And the reason you would have a dedicated device like that that's just for VPN would be what, Holly? When do you think you'd position such a device in to one of your customers?
I mean, we have edge devices, not necessarily tunnel terminators specifically. Um, But the use case is really you don't need it's not security that you're looking for on those devices. Like it's just you need a basic piece of hardware to terminate the tunnels. I don't know exactly why, but it's more
Well,
so you just don't need a specialized box doing all the security because you're not
I'll give you a
performing that
hint.
at that
I'll give
point
you
in
a
your
hint.
network.
The why is scale.
Yeah,
Does that help?
sure.
So explain the scaling problem that you think we might have if I have, say, thousands of VPN tunnels I'm dealing with.
Well, if you have thousands of VPN tunnels and they're all coming into, I don't know, 3 firewalls, you're going to have a problem.
And the problem is
Yeah.
tied to math and the fact that
Mhm.
we're doing a lot of encryption and
Yeah.
decryption. And so as you scale up from, tens of tunnels, hundreds of tunnels, okay, a lot of hardware can handle that. Now you're getting into thousands or maybe tens of thousands of tunnels. You might want a box that's dedicated to
Mhm.
just doing, VPN stuff. If whatever the kind of VPN is that you might be doing. Um, and that, yeah, I mean, again, you taking me down memory lane here, but way back in the day, Cisco had a whole series of devices called, it was the VPN 3000 series. They had 3015s and 3030s and 3060s and 3090s, maybe, if I remember right. Wow, I'm really going, wait, this is historical. This is definitely museum quality memories here we're going to. But the point of it was, yeah, your Pix firewall or ASA firewall can do VPN tunnels, but I mean, I was working for a shop that we needed as many as 10,000 tunnels at a time to support all the remote people that were out there, if I remember right. And so we had some VPN 3000 series concentrators that were dedicated just to that job so that the firewall could just focus on firewall stuff, deep packet inspection and inside to outside, trusted, untrusted, making all those decisions about whether that traffic should flow. And we left the VPN work off to the VPN concentrators. Now, one little thing here, this is still a security device. The
Okay.
VPN concentrator would be bounded and limited in the kinds of traffic it would support. It's not a generic router. It has a goal and a purpose, and that is it handles VPN tunnels coming into it from the outside, and maybe some that were going out to other partner organizations, and that is all it does. So it's sort of a very specific sort of router, a device that had been optimized to do routing, but with VPN tunnels. And it has that security function in that the way VPN tunnels are stood up and torn down, you've got specific devices with a policy attached to them that are governing those tunnels. So it's not a firewall, no, but it is a security device, and you
Mhm.
should. I would group it in there. I think you should think of it as such.
I did not mean to
Do we see a
derail
lot of
us,
those in
but
2026? I don't know. I don't know. You didn't derail anything. It's a good side conversation.
just
Good
a
side
thought.
conversation. Oh man. And so we got just a few more points here. I think hopefully at this point, now that we're an hour in, you kind of are out there listening. You're like, okay, I think I see how a firewall is different from a router. They are similar, but they're pretty different. Um, I just let's conclude this conversation. I just want to make the point that firewalls are cool. There's so much
Yeah.
interesting information on them. You get these logs of what's been dropped or in there. You get stats about what rules in the security policy are being hit or maybe not hit, which is be really interesting, useful intel to understand about your network. Get information from the firewall about the kind of attacks that the firewall is observing or that it suspects are occurring. You get awareness from the goings on in the world because as you look at cybersecurity, there are surges in different kinds of attacks that are happening and patterns that can be deduced from those. And your firewall vendor, they probably got a security operations center where they're tracking this kind of stuff. And you can see in your firewall management console what's going on, maybe. You can see who's logged into the VPN and from where. Bob just logged in. It's 11:30 in the morning. He's right on time. I'm sorry, that's not. I'm being unfair to Bob, but you can you can find out all kinds of information about what's happening in your firewall. It's just a cool box to get familiar with, jumping around on, and learning what's happening there. Don't be scared of it. You can hop onto the management console and just see what's there to be gleaned. Lots of cool data. When you manage a firewall, you might manage it individually if you're a smaller shop, an individual firewall at a time, or you might be managing it from a central console that can see all the firewalls in your organization and you're managing them uniformly. That's a thing. And certainly as you start adding firewalls, that's where you want to go because you want to build one security policy and push them to a group of firewalls, not you don't want to be managing one firewall at a time. You want to be managing a security policy that the firewall happens to be using and enforcing. Um, And so let me leave you with one wild card question, Holly, here at the end. Can you run a routing protocol like OSPF or BGP on a firewall? Can
Of
you do that?
course. Of course you
Yeah, of
can.
course you can. You can
Do
do it
you
on an SRX. I mean, for
Yeah,
sure. Yeah. Should you?
depends. I mean, that's where I learned how to do, routing on my
Yeah.
firewall. Um,
Yeah, you can. Now, this is another historical debate, and I bring up a lot of these historical debates because it helps people that are new understand how we got to where we are today
mhm,
in a lot of things. This was yet another debate. Should you run a routing protocol on a firewall? And back in the day, most firewalls did not support routing protocols. They supported routing, of course. Static routes were the most customary way to do things, but it wasn't a given that you'd have an OSPF daemon available to you or a BGP daemon available to you on the firewall. And when you would talk to the routing vendor about, or the firewall vendor about this and go, gosh, guys, it'd be so handy if I could run OSPF on this thing. They'd say, really, though, is that what you want to do? Do you want to have OSPF running as a process and become another attack surface for your firewall so some bad guy can try to attack the OSPF process and do bad things? Was one of the arguments that I heard from a particular firewall vendor back in the day. And the argument was the more stuff you're running on the firewall itself, the more you make the firewall itself subject to attack and make it potentially vulnerable. Okay, so do I want to run, a routing protocol on my firewall? Yeah, probably. Depending on the size of the organization, I do. That's probably appropriate and helpful, and a pain in the butt if I don't. Um, but it does bring up the larger question of how the firewall itself might be vulnerable to attack. It would suck if your firewall had a vulnerability that would allow an attacker to get control of it. Because if the road attacker can get control of it, they can update the security policy that allows them to get in and do bad things, and you're not even going to notice. It's not like they're going to kill your firewall and cut off your access. That's not what the average attacker is looking for. They want a way in so that they can get at the good stuff, the nougaty center that's inside your network. They want to get beyond the crunchy shell on the outside that's made up by your firewalls and other security devices. And so philosophically, it's like if I don't have to run process X on my firewall, I'm not gonna because I want to minimize vulnerabilities. And man, in 2025, at least Cisco, Fortinet, and Palo Alto networks, all of whom have massive security operations and have lots of firewalls and security products they put out the door, had major, big time vulnerabilities in their products that you were or were not exposed to, depending on how you operated their devices. So the philosophically then, don't turn the thing on in your firewall because it's cool. You turn it on because you need to. There's a specific business reason you need to turn on a particular feature. The less you turn on, the more you're reducing your risk that bad code your firewall vendor issued to your firewall is going to cause you a problem. It's going to cause a high risk vulnerability that you must react to and deal with, and potentially expose your company to the bad guys doing bad things.
Yeah.
So sorry
I
for the rant at the end, Holly, but
No, but
I needed to
it's
say
very
that.
valid because I think no company is perfect. No piece of software is perfect. There's always going to be, with any update, like, something might go wrong. There might be vulnerabilities, and you need to be aware of that, because I think often we think, oh, it's coming from, Palo or Cisco or Juniper or whoever, and they know what they're doing with their software. They do, but everything, at least at this very moment, everything's still created by humans, and things go wrong, or something was tested and it worked in a controlled environment, and then you put it
Oh,
out
yeah.
into into a public network, and it doesn't exactly work as was tested in the lab, and things go wrong. So,
And it's even worse than that. Sure, there's the humans that make mistakes, but then there's also shared libraries that
hmm
were previously secured, and you're using that shared library. Maybe it's an open source library that all of a sudden has a vulnerability. It's like, geez, now the open source code needs to be patched so that you're no longer vulnerable.
yeah,
Or there's a supply chain attack that is the process of getting the code from a developer's workstation through the system and through the pipeline and into the firewall could go through any number of different steps. There's a process to it. And if the bad guy can figure out how to get into the middle of that chain of events that happens to get the code from developer land onto the box itself and can insert themselves into the process, you'd never know what happened because it happened in the middle, in between what you issued, and getting it actually onto the box. That can be a supply. They call it supply side attacks. Can cause a vulnerability. So again, it's even worse than just a human. It's all these clever ways that folks can come up with to attack your box and get their code on your box and give them a backdoor into your network. Um, so I opened up the question with, can you run a routing protocol on a firewall? You can. Should you? Not if you don't have to. Do you have to? Probably, all depending on the size of your network. But think about that as a thought exercise for anything else that you might want to run on that firewall. Keep your vulnerability, keep your attack surface on the firewall itself at a minimum. Because I don't mean to pick on Palo, Fortinet, and Cisco. They were just in the news over the last 12 months because of severe vulnerabilities. Everybody, every single vendor will have a problem. Even a firewall vendor that you think, security guys, they know what's up. We trust them. Yeah, you will someday be facing a top tier vulnerability from those people that you trust and love very much. It's the nature of it. So you have to think about it architecturally. How do I minimize my exposure when the inevitable bad thing happens and I have vulnerable code that the bad actors can go after? Whew, another short show, Holly. We kept it.
yeah,
Oh crap! I was gonna say we kept it under an hour. We didn't. We didn't even do that today. No.
we tried.
We
You know,
did we though? Did we try?
I mean, the problem is that sometimes things come up, and we want to chat about them, and hopefully people enjoy it. So,
Yeah, I think so. You keep telling us that you enjoyed it.
yeah.
So thanks for listening if you're out there and enjoyed this show. And if you have comments or questions about this show, or you have actually observations because you didn't like the way we phrase something or another, probably me, you can tell us all about that at packetpushers.net/follow up. We get lots of follow-ups from you out there. We appreciate it. We build shows around them, or we build shows because of them. All depending on what's happening. They're great things. Now, the follow-up form, if you go to packetpushers.net/follow-up, that form is not the most scintillating of pages on packetpushers.net, but there are a lot of other things on that site worth clicking on. For example, we got lots of other free podcasts. You can find our YouTube channel from there. We've got our 2 weekly newsletters. We got a Slack group and more. And everything you find on packetpushers.net is completely free. We don't require a login. There are no strings attached here. We're not tracking you. Just explore and see what we're offering that might help you in your career. And we are lining up guests for shows in MPLS and Multicast, and there's a lot more that we have in development right now. So you can follow us, Holly Metlitsky and Ethan Banks, on LinkedIn or that Packet Pushers Community Slack group that I mentioned earlier. And feel free to DM us on those platforms. We'd love to hear from you. And last but not least, just remember that networking isn't hard. Other people figured it out, so you can too.